Hi folks, thank you for checking out this video. In this video I would like to introduce a suite of development tools, development, packaging, code management tools for Erlang. The purpose of this tool is ultimately to make it easy for end users to run programs written in Erlang instead of having a basic requirement that everybody who wants to execute an Erlang program be a system engineer or an Erlang engineer, or be or have your project include a bunch of installer and packaging work the way that like Wings 3D. Wings 3D is probably one of the biggest end user GUI programs written in Erlang. And of course they do their own Windows installer. They do packaging work for various Linux distributions to get a hold of it, and they have a OS 10 installer and so on. So to eliminate that work and kind of make that go away, I've made a development tool called ZX that works together with a code distribution hosting tool called Zomp. And together, those two things are able to help you template projects, package those projects up, and then get those packages out into the hands of users in a simple way that doesn't have a single centralized repository and doesn't use GitHub as a repository, doesn't use GitLab as a repository, and does not depend on a single package repository that's like a single enormous repository like the way that the Elixir community has. So, without further ado, the tool is written in Erlang, so of course a requirement is that you have Erlang. ZX requires version 21 or higher of Erlang. If you look at the Debian stable repository, I believe it has like release 19 right now, so that won't work. You just build a new one. I personally use curl. Lots of people have different ways of getting Erlang. Erlang Solutions provides system packages for different distributions, as well as Windows installers and so on. So once you have Erlang, go to the ZX page, go to Quick Start, install Erlang ZX. So of course you need the Erlang runtime, which we've already got, and we need ZX. So getting ZX, the easiest way to do it, there's a script called getZX that will bring it to our system, and that's it. It just automates the steps that are below that on that page, the installation page right there. So this is editing our environment a little bit and building itself. So now we have ZX. If I do ZX version, it will tell us what it is. So the goal of this tool is to make it easy for end users to run programs. So we're going to do that right now real quick. Let's pretend that we're a user and I want to run the Erlang version of Minesweeper, which I wrote, I don't know, a few months ago when I was bored. So if I do ZX run Minesweeper, it gets the package from the network, builds it, and it runs it. So now I can play Minesweeper, which this turned out to be a very easy level. If I do the same thing again, and note, it gives us the version number of which Minesweeper was selected. If we don't provide a version number here, ZX will always default to the latest version of whatever package you pick. So for end users, that just means that they get, as soon as you release an update as a developer, the end user gets that update the next time they run the program. And that goes for any kind of code that ZX is launching. So here we don't see any build steps, and that's because it's already on the system, it's cached here. They don't actually need network access anymore to run this. If we want to see what versions are available, we can pick a specific version by adding a version to the end and seeing what happens. Okay, so now it's building something because we don't have that version cached on this system, and we picked a specific one. So if we use this specific version again, of course it'll run that same one again. There's an additional tool called Vapor, and it is a GUI launcher for GUI programs. So if I do Vapor is launched by ZX. It's just a ZX program, but it uses ZX facilities to display what GUI packages are available and lets users pick them to run. So if we run Vapor, we'll see Vapor build here briefly, because of course that's needed, and a dependency build ZXW. So let's say we want to play Minesweeper from here. We pick it from the list, run, and it's open. Vapor also allows us to. Vapor's still very beta right now. We don't. Obviously, this isn't very pretty. This is only giving us the listing that we would get if we did CX describe a package name. On the roadmap, what I've got is to change this field here to an HTML render that we can pull from a project, a path that you put in your package metadata, to let Vapor pull and render a little HTML window that's a little bit prettier thing for you. Same thing with a run button. We can make that an optional image. And then if you don't have any of those things, if you did make a website for your project, then it'll just show like this. Maybe I'll make that a little bit prettier somehow. Anyway, we're starting to get, because development of Erlang is kind of ugly and tricky on Windows. I'm looking at putting some developer features into Vapor because the command line on Windows is really nasty, and ZX is primarily a command line tool. So making Vapor into a more kind of all-encompassing interface to the ZX world, but from the GUI, to help Windows Erlang developers kind of get on their feet and take advantage of the ease of development that ZX provides. So in that direction, we can start Observer actually, and run Observer, which this is something people from other languages might not even understand what's going on. Observer lets us see into the runtime and see all the processes that are running, who's talking to what. So this is Vapor that we're running right here. Vapor has a supervisor, a controller, and it spawn links actually. The GUI process this window right here. So we could look into that and take a look at its state, trace what's being executed, and so on from here, which is pretty nice when you're a developer. So if we run Minesweeper, we'll see Minesweeper pop up as a new application actually, and we can see what exists in Minesweeper too. And when we shut that down, it'll all clean itself up and go away. So that's Vapor. On Windows, that's the default way to run programs. There's a Windows installer, like traditional Windows installer for ZX, that's actually called Get Vapor. It's not. I think it's called Install Vapor. ZX is sort of one layer back behind that for Windows because, again, command line tools on Windows are just kind of messy unless you're a developer and deal with it all the time. So anyway, the end result is that we can use ZX to write a GUI program in Erlang, package that, put it into Zomp, and any Windows user with Vapor on their system can click Vapor, pick your program, and it'll just run. And that's it. There's no installation steps necessary for that user. They don't have to do anything crazy. It's just in the package listing already if they have, if their ZX installation has visibility on your code realm. So that's it. So let's use ZX right now to template a project. ZX has just a couple of project templates that if you're a new Erlang developer and you've just gone through some hello world code and maybe you've written some command line e-scripts so you can do some basic coding in the sequential part of the language, ZX will help you get over the hump of going from that sequential Erlang kind of hello world type experimenting code over to the world of OTP applications where there's a lot of structure and many more modules and there's supervision concepts and things, processes are monitoring or linking to each other and so on. that world suddenly gets, with Erlang, you start learning Erlang, you look up some tutorials online, you go, oh, this is kind of a neat language. It's very simple and consistent. What a nice little tiny language. And then you go, well, how do I make a big chat server from that? And you look at chat server code and you're like, oh my God, so many modules. And you just get thrown in the deep end immediately. Even though each line is easy to understand, what's going on behind it with OTP, what's a gen server, what's a gen statem, what's a gen FSM, and so on. Those things can be really perplexing, and you have to understand what's going on with application, and there's a lot of documentation you have to read to get that, to understand why a program is structured the way it is, and to even come up with any kind of structural patterns that help you express your idea of a program as different processes working together uh, to make your program work. So ZX has a couple of templates to help you get that to happen, and one of them is a template for a GUI project, just like the Minesweeper one we just saw. Uh, so let's go to a code directory. Everybody's got something like that on their system, and we're going to do ZX create project and select a project type. Okay, I want to make a GUI. The project name. Now this is the display name, so it could be in anything. I live in Japan, so of course I would name something, if it was for my friends to use, probably in Japanese. Um, Here we're just going to do show args. Now the template project itself, by default, that's all it does. It opens up a WX window, it's got a text field in it, and it shows you whatever arguments were passed at startup time. So we're just going to go with that for now. Package realm. I'd mentioned Zomp earlier is the package distribution system, and you can host your own code with it in a simple way. Realms is sort of realms are analogous to package repositories for a Linux distribution. Um, Inside of it, package names have to be unique. You may have a mixture of different repositories from which you're getting code, right? So ZX gets configured for a realm. A realm has a prime Zomp node somewhere out on the net that it can get to, but anybody else running Zomp, you can just do ZX run Zomp, because Zomp is a ZX run program itself. Um, and it will find any other nodes for which your ZX installation is configured, or any realms for which you're configured, and it will start mirroring the packages as they are requested by Leaf clients that are trying to run code. So the requests actually go up a chain to the core node, or to the prime node for a realm. If the package doesn't exist when it's requested, the request is forwarded higher up the chain, and so on. So there's kind of a tree of code redistribution, and any kind of popular package, once it's requested once somewhere, it's copied all down the chain. Um, so there's very few requests actually that make it all the way up to the prime node most of the time, which avoids a lot of issues with redundancy and trying to have a big infrastructure. You don't Zomp and ZX code is very, very lightweight on hosting. So anyway, I mentioned that to explain what package realm. Normally, if I had several realms configured for the ZX installation right now, it would ask me which realm this project is supposed to be a part of. We've only got one realm, so it picked OTPR, which is the default realm. That's where like the central kind of open source code lives. So it picked OTPR and it just moved on. Package name. Your package needs to have a name. So now we already picked the project name up here, but the package name is something that ZX and Zomp care about. So it's got a couple of naming convention rules. So we're going to call it show_args version 1, picking a prefix. As you probably already know, Erlang doesn't have namespaces the same way that like a language like Java does. So a common practice inside of the Erlang world is to take an abbreviation of your project name, put an underscore after it, and that is your module name prefix for all your modules, and that way there's, you know, it's rare to have name clashes. Uh, because Erlang execution environments typically only involve the modules that are required for a specific application to run, um, naming conflicts are actually quite rare because they're not system-wide conflicts. This is a little bit more like when you run a project with ZX, it's more like running inside of Python virtual environment. Uh, if you build a traditional Erlang release using a tool like Rebar 3, um, only the code involved in that project will get included in that project. So, you know, there may be many different modules named something, but if they're not included in the same project instance or runtime instance, then there won't be any naming conflict. So anyway, the prefix here is to help prevent name clashes within a single code realm. And ZX, when you're coding and you start adding dependencies to your projects, ZX can help you see if there's going to be a naming conflict by checking what names exist already out there in the realms that you have configured. So we're going to use the default SA prefix here. That's just an abbreviation of our show args thing. Author name, that's me. Email, that's me also. I already get spammed, so whatever. I'm just picking the MIT license. You can pick whatever you want. Short project description, show provided args in a GUI window. Repo URL, we don't have a repo for this. Project URL, we don't have a project website either. These can all be edited later using a metadata update command for your project packages. Now, application data confirmation. This is just showing us everything we entered so we can double check before we hit enter. And we're just going to do that now. So now there is a directory called show args right here. If I want to run this from here, I can do ZX run dir show args. If I do that, it will build another project for us. So I can make an edit and then do the same thing again. If I go to the show args directory, from inside this directory, I would need to do run local. There's a couple of reasons for that, but anyway, run local does the exact same thing that run dir did. It just runs the local project. Run local's just a required, that's a slightly different command, and it's required for running within the actual project home directory itself. Now, what happens when I run this program? Let's give it some arguments. Foo bar baz. Received args foo bar baz. Okay, well, this is pretty simple. If we check the source directory for this, we have the show args module that represents the high-level interface to the program. So if we check that out, we see it exports two functions only, start two and stop one, and here we are, it's an application behavior, which is a standard OTP thing, and that's all it is. There's nothing much to GUI code in terms of system-facing interfaces. There's just not much there. The supervisor only starts one thing. It's got one child, which is the client controller, and that's it. It's just the controller. If we open the controller, it also has a very simple interface. What happens when we initialize it? It gets this argument is being put in here. It just starts it. It tells the GUI to start, and you notice this is start linking. SA GUI is a process that is going to be bound to the WX server that is talking to the window manager. So we don't put it under supervision the same way we would put another process because we don't really need to. We're going to go ahead and make SA GUI and SA controller just attached to the hip. They're linked, so if one of them crashes, the other one crashes immediately, and that'll wipe out our system. The reason for that is there's not if you make WX barf, it's running in the context of the Erlang runtime, so there's not a lot of things you can do to rescue it. So you just want everything to die at once instead of having a leftover runtime that's got like an Erlang supervisor with one child that can't talk to anything just out there as a system orphan. That's a bad thing to do. So instead, if one of these crashes, the other one will crash and the whole thing will die, and we can find out. It's easier to debug that way than having kind of zombie processes like sitting around. So it's start link. We're passing it a title. We saw the hello WX in the window just a second ago. Hello WX, that's where this comes from. So the title's coming from there. If this was a more interesting program, we could do any other thing that we want with it, that window title. And then this window we set as our only state variable is window that we keep, and we pass that on back the same way that we do with any other gen server code. So now let's take a look at, oh, I'm sorry. After that started up and we get an identity for it, on this line we're calling the ZX daemon. The ZX daemon keeps track of a lot of runtime things. It can make network requests for you within the Zomp system to find out about packages, and it has a lot of background utility functions. One of them, which is important enough to have its own function name, is get your list of arguments, the command line arguments. So we're going to get the arguments from the daemon because it knows what they are, and we're going to tell the GUI to show these arguments. And as we saw, it's a list of strings, which is the same way that you would get those arguments if you write an E script. Your command line arguments are just a list of strings. So let's go over to SA GUI and see what happens at startup time, and then what happens when we call show. So SA GUI. So let's check the init function. Oh, and there's some. So we've got some WX stuff going on. We're starting a new WX server. This is running in the context of the Erlang runtime, and it's talking to our window manager so that we can get something on the screen. We make a new frame. We do a little bit of window setup here, and we connect the close window button, the X type button. It's like on every GUI system. We're going to connect to the close window event so that we'll get a notification if somebody tries to close that. Otherwise, they can click it, and if we don't get that event, we just sit there not doing anything. We're going to center the frame on the screen, and then we're going to show the frame. And that's it. Now we've got a text control that we've created up here. It's a WX text control, so we've got that text frame where we're going to actually show the where the args are, and then the frame itself, we need to keep track of that if we're going to create anything else in the window and clean up properly. So what's our interface function here? The interface function, remember, we don't call init ourselves, right? That's something that StartLink does, and WX object does that stuff. So this is like the boilerplate mechanical stuff, and it's the first thing that happens when the process is initializing itself, and you look in the WX documentation to know how to write that as a callback. This is our own up here show. That is our own little interface function, and that's the thing that the controller calls with the arguments list. So let's check out. Look, we're doing WX object cast. So let's look at Handlecast. And here we go. If we receive this message, we're going to call a function called doShow. which, you know, anytime you see something like this where it's just okay, we're not updating state, it's like a pure side effect, which is exactly what's happening here. We're getting a list of terms. We're formatting them with this message, received args terms, and that's it. And that's how it works. So let's go back here for a second. Sorry, that's really tiny. Can't read that on YouTube probably. So we'll run local. No arguments, right? Empty list. Run local, some arguments. Now let's say I want to edit and change the way that works. Like let's put a new line here, just because. Now the workflow would be I edit that, and then I want to run it again to see what happens. So it rebuilt that one module that we edited, and we actually did get this effect. So that's it. That's the cycle when you use ZX to develop programs. Is you make an edit, then you go over there and you run local, and that's it. That's the whole. Like that's as hard as it is. Nothing else is necessary to get things to work. Beyond that, when you want to put something into a repository, the realm, whoever the realm administrator is, if it's not your own realm, if it's your own realm, you do, you know, ZX create package or add package, I think, and it'll create an entry for it, and then you can submit your code package to the realm, accept it into the realm, and then from that moment on, it's available to everybody. Same thing with if, like for example, you want to put a package into the OTPR open source realm, so like everybody could see it with no extra configuration to ZX, you contact the realm administrator, which is me. I make the package entry for you and then designate you as a user with the authority to manage that project. And from then you can submit updates to that package, new package versions, and whoever is the realm administrator, whoever owns the realm, is responsible for the final acceptance into the realm. So it can be approved from within the project itself, but to be actually published, because code could be dangerous, right? The responsibility rests with the person that runs the realm, or who, you know, however many there may be, and that's it. From that moment on, anybody can, you know, run code. There's one more thing about ZX that's interesting. Until now, we've been doing ZX run local. So let's look at this previous command. If we do ZXH, what that means is head. The head stands for H. So ZXH actually gives us a shell. So from here, if we wanted to use like sys commands to inspect the runtime state, you know, like if we want to check if a process is alive or get its PID or inspect its current state or whatever, we can use the shell here to do that. We can also, of course, exit from here. You'd notice that window just disappeared. Anyway, having a shell is very useful for a lot of reasons when you're in development. So sometimes you want to run ZXH and then your project. And some projects kind of require that. If they require interactive startup, there's a lot of tools that sometimes work that way. So just keep in mind that you can get access to an Erlang shell without connecting a different Erlang node to it. You can get a shell straight away just using ZXH instead of running the purely client-focused ZX only command. Like you wouldn't want to run ZXH with, like, if I do ZX list packages OTPR, right? I wouldn't want to run that command as ZXH list packages, because that would be silly. That shell would exit like immediately, and it would mess up the output. So I wouldn't want to do it that way. Anyway, that's how. This is one way that we can develop projects in kind of a quick way, um, with a tight iteration uh, between making an edit, running it and see what happened, make an edit, run it and see what happens. So you can get minimal incremental improvement. Um, ZX also has templates for just a basic telnet chat echo server, if you do the traditional Erlang application, and that also has the OTP compliant process template supervision and so on. With it's a networked application already. Most Erlang applications are, of course, network utilities that are for the back end chat servers, game servers, business data servers, and so on. Telecom streaming stuff and whatever. Uh, but the world is open now for doing Erlang GUI programs, and a Windows user can click on their desktop, uh, click to run Vapor. Vapor opens, and they can pick any of these programs and run them. So, you know, my friends that are on Windows that wanted to see the Barnsley's Fern experiment were able to do that without any trouble. So they were able to get this exact same thing on their screen just by clicking from Vapor the Barnsley Fern experiment and then reading the code and seeing what it does, um, that was a nice thing. So as I said before, Vapor is very beta ugly right now. It's functional, it works, but it's very beta ugly right now, and there's a lot of beautification that I would like to do to it. Um, but anyway, this is kind of uh, a new way of doing Erlang code in kind of uh, a way that may be more familiar to developers that are coming from Python or Ruby or another language like that, as opposed to the traditional Erlang release. Using rebar to build a release, and then you put the release on the target system, and then run it that way. Almost always demonized as a system service. Um, that's a great way to do things for the server side, and there's a whole world of DevOps workflows that are built around that, and that's a great thing. This is not really a replacement for that per se. Though running a private realm inside of a large infrastructure is a very easy way to configure systems to run your code if you're doing a large DevOps deployment. But ZX is especially focused on trying to get programs out to end users in a simple way, without making the developer have to write installers for every different platform you might write for. As long as you write your code in vanilla Erlang, it'll run anywhere that Erlang will run, which is that's a tremendous amount of portability. I've got support for NIFs written in Rust, is on the roadmap. Bringing in support for Lisp flavored Erlang, the LFE, Lispy language, as a peer language, so that you could have a module written in Erlang and a module written in LFE next to each other, and they should just work. That's also on the roadmap, but I haven't gotten there quite yet because, of course, this is my personal thing, and got to pay the bills. So, as time permits, I would like to do more of this, especially beautifying Vapor. That would be really, really cool. So, anyway, that's how things work. And if you find this useful, or if you find that this kind of helps you bridge, especially the templates, like bridging the gap between some of that elementary, you're just learning Erlang if you're a new Erlanger, um, going from the simpler code to the more complex code with more structure to the project, or robustness if you do like an Erlang application style instead of a GUI. Um, you know, Explore those, keep reading, keep having fun, and hopefully this is helpful to somebody other than just me. So that's ZX and Vapor and Zomp, and let me know what you'd like to see changed or improved, or if you have questions, feel absolutely free to contact me. I'm on IRC, Discord, my own website, email, the mailing list, you name it. I'm out there. I'm on the Slack, the Erlang channel on Stack Overflow. I'm pretty much I'm easy to track down in the context of Erlang stuff. So hope you guys have a great weekend. Keep doing creative things. making things is a lot more fun than breaking them. It's much more fulfilling. So let's focus on that stuff and continue to have a super amazing, fun 2020. Bye bye.